Okay, so pretty basic question here. This is simplify. So just to make sure you understand the goal, we're going to first start by simplifying these, and then we're going to start verifying. So simplifying is the easy part. The biggest question is, how do I know when I'm simplified? So with these questions, your goal is to simplify these expressions into either one single trig function, whether it's sine, cosine, tangent, secant, cosecant, cotangent, or even maybe sine squared theta, cosine squared theta, tangent squared theta, secant squared theta, cosecant squared theta, cotangent squared theta. At first, your first strategy should be, should I convert all the factors that I have here? There's three factors into sines and cosines. That's usually the first step that students head towards. So sine theta is already in terms of sine. Secant theta is the reciprocal identity of cosine. So I can replace secant theta here with 1 over cosine theta. And cotangent, you got to be careful with this. Often students want to convert cotangent into its reciprocal identity, which is 1 over tangent theta. But if we're trying to convert to sines and cosines, converting cotangent to 1 over tangent isn't going to be helpful. So you're going to spend not most of the time, but you're going to convert cotangents into sines and cosines way more than you're going to convert it into 1 over tangent. Okay, so sine theta stays the same. Secant theta becomes 1 over cosine theta. Cotangent theta becomes cosine theta over sine theta. Now this is the product of three fractions, right? And you can simplify. So I like to simplify before I multiply, and I notice that cosine theta in the denominator here is the same as cosine theta in the numerator here. So these two will simplify to 1. Sine theta in the numerator on the left, sine theta in the denominator on the right, those will simplify to 1. So now everything is in terms of 1. So 1 times 1 times 1 divided by 1 times 1 times 1 is going to simplify to 1 for us. Right? Oops. Here we go. All right, next one. Secant x minus sine x tangent x. A little intimidating, but just be careful. This is a subtraction, and then this is product of two factors. Again, sines and cosines are your best bet here. So secant x becomes 1 over cosine x minus sine x is sine x. I express it as a fraction when I write it. And then again, tangent x, if you're converting to sines and cosines, don't convert this to 1 over cotangent. It's not going to help. Convert it to sine x over cosine x. And this one's a little bit more complicated at first, right? So at this point, you really can't simplify at the moment numerators to denominators, but you can multiply, right? So sine x times sine x. When we're multiplying fractions, we multiply the numerators, we multiply the denominators here. So now I have the original left term, 1 over cosine x minus, and then now I have sine squared x over cosine x. And this is where your knowledge of working with fractions and rational expressions is going to be very beneficial. So we're subtracting two fractions. The denominators are the same. Occasionally, you'll need to make common denominators the way you would in any other rational expression. So I'm going to condense this into one big fraction where the numerator is cosine. So it's going to be 1 minus sine squared theta right here over cosine squared theta. Now, we're not simplified yet. This is where we're going to use our first Pythagorean identity. See this 1 minus sine squared? I look for the Pythagorean identities as soon as I see a trig function squared, right, being added or subtracted from 1 or added or subtracted from another trig function squared. So the sine squared and the 1 make me think the original Pythagorean identity here, right? So this is the one that we work with. And I need to view it as 1 minus sine squared. So I'm going to subtract I'm going to subtract sine squared from both sides, leaving me with cosine squared x equals 1 minus sine squared x. So now I'm going to replace this 1 minus sine squared x with cosine squared x. And I have cosine squared x over cosine x. This is similar to simplifying, a fraction that's a squared over a. Cosine squared x over cosine will simplify to just cosine, and now I have one trig function. It's simplified, and that was my goal here.